Sweet. All right. Welcome to another live stream. And what I want to do in this live stream is cover our second quiz that is covering functions. So this is quiz number 2. And what we're going to cover in this one is a quick little quiz, just kind of covering piecewise functions, operations of functions, as well as inverse of functions. And what I did is I have some 4 kind of free response questions, and then I have some multiple choice questions as well. So what my goal here is to just kind of run through the answers and do some explanation as far as how I arrived at my answer for my students to check their work, but then also for students that are interested in learning this material. And then obviously for any of you guys that are joining now or, at the end, if you have any kind of your own questions, I'll be more than happy to kind of answer those. So let's kind of get right into it. I have, just about 30 minutes that I want to spend with this. So I'm going to kind of work through them, and then I'll take a break here at the free response until I get into the multiple choice. So, all right, here we go. The first one says, graph the following piecewise function to label the discontinuity, and then determine the domain and range and evaluate for f of -1. Now, I didn't really kind of check back after I kind of graded it and looked at the students' answers. I realized there were some issues with how I worded some of these questions, so I'm going to go back in and fix some of those errors. But for right now, I'm just going to adjust with what I currently have. So the main important thing, we need to graph these. And what I told my students when we're looking into graphing piecewise functions, the first thing we need to understand is, what is the parent graph? And so what we see is we have 2 parent graphs here. We have the quadratic, which the parent graph looks like that. And then we have a linear equation, which is basically the identity element, which is just going to be a line like that. All right. Now, we could use transformations to understand the equation, but I think it's really easiest to just graph a line based on how we know how to do it. So first of all, let's go ahead and graph the piecewise function. The quadratic function. And basically what we're going to do is this quadratic, since we're adding one inside the function, that's shifting the graph 1 unit to the left and then shifting it 1 unit up. So this vertex, which is at 0, 0, is now going to be at -1, 1. So it's going to have basically a shape going that way and a shape going that way. So that is what the graph looks like with the transformations. However, we have these domain restrictions here where this says only graph this function for x values that are greater than -1. So that means anything, let's go ahead and place -1 here. So x equals -1 is right there. So then anything to the left of that is not going to be within the domain. So what I'm going to do is just erase that. All right. And it's greater than, so I'm going to take out that dot. No, dang it. I thought I made that dot separate. But since it's greater than, it's not going to be equal to. So I'm going to use a open circle and graph. All right. The next one is, I'll use a different color, I'll use purple here. And this one's 2x minus 4. Remember when graphing linear equations, you're going to go to the y-intercept, which is -4. Okay, and then the slope is -2 over 1. So you could go down 2 to the right one, or what we see is we're going less than -1, so we're going to want to go to the left. So I'm going to go up 2 to the left one. And then I can go up 2 to the left one more time, and then that gives me enough to create my graph, which is not that nice. Actually, I want to stop that. I want to graph it from there to there, and then from there to there. Okay, but again, noticing my domain restriction here, it says only graph this function 2x minus 4 for x values that are less than -1. So therefore, I'm going to delete that portion. So you can see here that is what my graph looks like. Now from there, I can go ahead and identify the discontinuity. You can see there is a jump discontinuity. So we say a jump discontinuity at, and then we want to label where it is, at x equals 1. And we can also talk about the domain and range. So the domain, you can see that even though it's undefined at -1 for this function, the function is defined at -1 down for the linear function. So my domain is going to be all real numbers. And my range, though, however, only goes down to -2 and goes up. And you can see at -2 it is defined. So I'm going to use brackets for there. And then last but not least is going to be f of -1, or evaluate the function at f of -1. So basically what I'm doing is I'm looking for where is the value of the function at -1. Well, we can just use the graph here and see that the graph at f of -1 we don't really need to use our algebra here. We can just say f of negative 1 is equal to negative 2. However, if maybe the case, where the graph is not very easily understood as far as what it looks like, we need to be able to determine which function we need to plug negative 1 into. We're not going to plug it into both. We can see that this function, the negative 2x minus 4, is for only x values that are less than or equal to negative 1. So that's going to be the function that I'm going to want to plug it into. So I plug in a negative 1 in for x. And you can see here negative 2 times negative 2 is going to be a positive 2. Minus 4, which equals a negative 2. And again, you get the same answer, so the graphical approach or the algebraic. And I think that was everything I needed to do. It was. Sweet. All right. Now the next one, determine the value k that makes the function continuous. So what we practiced a lot was, when you have a function you're trying to find a continuous is, set up an equation, that is going to be set up the equation that you want the two functions to equal to each other. Well, we have an equation here which is just k, and then we have this other rational function here. So I have 3x squared plus 6x divided by x equals k. And if this function is continuous, at k, it's going to be continuous when x is equal to 0. So what we're going to do is we're going to want to plug in 0 for x. But the problem is we can't do that because when we plug in 0 in for x, that's going to make the denominator equal to 0. So what I'm going to do is I'm going to want to simplify this rational expression. And by doing that, I get 3x over x plus 2 all over x equals k. And then you can see here the x's divide out to 1. So what that's telling me is at x equals 0, there is a hole. So now I have x plus 2 equals k. So now to determine the value of k when x is equal to 0, I can just replace x with 0 and then solve for k. So I have 3 times 0 plus 2 equals k. Well, 0 plus 2 is 2. 2 times 3 is 6. So 6 is equal to k. All right, next example says compose the following functions f of g of x, and then I did change this for other classes. I said take off the range, but I also want you to figure out g of f of x. Now, this is where a lot of students' work got very sloppy, so I really want to be kind of clear with this as far as our mathematical writing here. A lot of students just kind of splattered their work on the paper and asked me to understand what they were doing. So it's really important when we are communicating mathematically that we are using proper notation. If I'm going to identify f of g of x, again, that is telling me that I'm going to be plugging the g of x function into the f of x function. So I'm going to write it out, that f of g of x, that equals, and now basically I'm going to plug that in. I'm going to replace the x with the g of x. Now I'm not going to I didn't expect my students to do this as far as this extra step, but I'm just going to do it for those of you that maybe this might be a little bit more of an introduction video for you. So whatever's inside for my input in function notation, that's what I'm going to replace with my x. But what I'm looking for is students to continue their work and their arguments by using equations. So this equation is equal to, we now have g of x defined for x plus 2. So I'm going to replace g of x with x plus 2. So that equals x plus 2 squared minus 1. Now I told the students that I wasn't concerned with their simplifying process at this point. I really am just more focused on them being able to identify the domains. And because obviously we can work on simplifying this and getting it to the correct process. And to simplify this further, you could you just multiply x plus 2 squared, which is x plus 2 times x plus 2. So that's going to give you x squared plus 4x. And then it would be plus 4, but then you're going to minus 3, so therefore it would be plus 3. All right. However, we don't really need to, if we want to have this simplified answer is here, good. But this answer is really the same process, just without the simplifying algebraically. But the important thing is I can find the domain from this without actually having to do simplified form. So again, by composition, what I have to do is I have to be concerned with what is the domain restriction of my initial function, which in this case, my function does not have any domain restrictions. It's negative infinity to infinity. However, once I plug g of x into the f of x function, I'm plugging it into the denominator. Now I have a new restriction because I have a new function in my denominator. So I'm going to set my denominator x plus 2 squared minus 1 equal to 0. Now, if you simplified it and you wrote it in that way, that's kind of nice too, because I'll get to that point, because some students made a mistake here. So you'd want to add a 1 to both sides, and then you'd have x plus 2 squared equals 1. Now, when you introduce to get rid of the square root, you got to take the square root of both sides, and therefore you'd have x, oops, I don't want to use parentheses anymore. I'll have x plus 2 equals, now again, when you introduce the square root, you got to use plus or minus 1. So then I subtract 2 on both sides, and I get x equals, let's see, positive 1 minus 2 is negative 1, and negative 1 minus 2 is going to be negative 3. So we have two values that make the denominator equal to 0. We can also show that by using factoring, because if you had this, if you set this denominator equal to 0, x squared plus 4x plus 3 equal to 0, you can factor that, because what two numbers multiply to give you 3, add to give you 4? That's going to be x plus 3 times x plus 1. And then, using the zero product property, x plus 3 equals 0, x plus 1 equals 0. So you can see that those solutions are the same as what I did over here. So it really just kind of comes into, if I asked for simplifying, and I didn't ask for simplifying in this case. I didn't, if students did it, that was great, but that wasn't my major concern. My major concern was students looking at the domain. Now we still need to write the domain here for this function. So the domain is all real numbers except for negative 1 and negative 3. So I'm going to do this in red. So if we look at this as far as like on a, let's do it on a number line here real quick. This function is defined for all values except for negative 1, so there's a hole, and a negative 3. It's not really a hole, but these are undefined values. So it's true for all values except for negative 1 and negative 3. So my domain contains values from negative infinity to negative 1, and then from negative 1 to negative 3, and then from negative 3 to infinity. And that is the interval notation for domain. And you could use union symbols, but in this case I am just doing it a different way. All right, let's go and get into now g of f of x. So now g of f of x, what I am doing, so again I'm saying, all right, now I'm doing the problem g of f of x, and that's going to equal me plugging in the f of x function into g. So it could look something like f of x plus 2. Well, now I have f of x defined here, which is 2 over x squared minus 1. So therefore I set another equal sign, so 2 over x squared minus 1 plus 2. Now in my class we haven't reviewed, combining rational expressions, so I didn't expect students to try to, add them. It was great if they went to that simplifying process, but it just wasn't something that we spent a lot of time with yet, because we're going to do that shortly, or in the upcoming chapters. So in this one, we really just need to understand then, well, we have a constraint now, right? The input value, when I look at my domain restriction, I have a domain restriction of the function that I inserted into the other function, which is x squared minus 1. And that domain restriction is the same as when I apply composition. So basically, from this point, I just need to figure out what values are not in the domain. And that's going to be the values that make the denominator equal to 0. So again, when I add, you could do factoring this. You could factor by difference of two squares, but usually the square root method is going to be the easiest. The only problem with the square root method is remembering the plus or minus. Oops, x equals plus or minus 1. And that's just one of the more common ones. That's why I kind of like, for students just to kind of recognize the difference of two squares, especially once we get into polynomials. We use the difference of two squares a lot, so it's nice to kind of recognize that, oh yeah, there are two solutions there, the positive and the negative solution. So now let's go ahead and write the domain. It's going to be the same thing, but my undefined values are at negative 1 and 1. So for interval notation, it'd be negative infinity to negative 1, union, negative 1 to infinity, and then 1 to infinity. Nope, that's not right. Sorry about that. Negative 1, negative infinity to negative 1, negative 1 to 1, and then union 1 to infinity. So for those of you that like the unions, that's all I'm doing. The only difference between these two is I'm just using the union symbol to be connecting them. I don't know why I decided to do unions there. Obviously, you'd want to be consistent, but I guess for some teaching purposes, I decided to switch it up. All right, last but not least is determine the domain and range of the following by finding the inverse. So I don't really like my directions here. I would have changed those up, and I am going to change them up because it really just tells the student to look at the domain and range. So it really makes the problem really, really easy as long as you know what the graph looks like. And we don't really need to be concerned with all these transformations because the cube root function, let's just call this like g of x. The cube root function, looks like this, where the domain and range is all real numbers. So remember, the domain and range of the inverse is swapped with the domain and range of the function. So if the domain and range of this function is all real numbers, that means the domain and range of my inverse, so f inverse of x, is going to have a domain of all real numbers and a range of all real numbers. So we can answer the question, fairly simple. And if we needed to show the inverse by finding the inverse, because you didn't really need to find the inverse, all you need to do is just reflect the graph across the y equals x line. However, my intent of this problem was for students to be able to algebraically find the inverse. And so that's where I wanted to rewrite, that's the way I wanted to write the question, but it obviously didn't come out that way. So for the spirit of algebraically finding the inverse, let's go ahead and do that. So the first thing we're going to want to do here is replace the f of x with y. It just makes our math a little bit simple. And then we're going to replace the x and the y. So therefore I'll have the cube root of 4y plus 1 minus 3. And now basically what I'm going to do is I'm going to use inverse operations to solve for y. So you can see that I have my cube root function here, and I have a y inside of the cube root. So what I need to do is apply my inverse operations to isolate the cube root. So the first thing I'm going to do is add a 3 to both sides. So I have an x plus 3 equals the cube root of 4y plus 1. Now that I have the cube root isolated, I can get rid of it. And using the inverse operations of the cube root would be to cube. And a lot of students made some mistakes by cubing. I would just, again, focus on leaving this. It wasn't anything that I really was concerned, or marking them down with the cubing, because obviously we're going to study this more in chapter 2. So we have x plus 3 cubed is equal to 4y plus 1. And now it's basically like a two-step equation on this side. Obviously we have this binomial cube, but you're going to want to subtract a 1. And I'm actually going to have to work this. So I have x plus 3 cubed minus 1 equals 4y. Now, again, in this case, I'm running out of space, right? So you can see, though, how my equation kind of follows this pattern. I'm just going to rewrite the expression over here. So therefore, I have more space, and it makes mathematical sense. Now I'll divide by 4. And then I'm just going to replace the 4's divide out to 1. And now, instead of solving for y, I'm just going to go back and replace the y using my inverse notation. So therefore, this would be f inverse of x is equal to, now there's a couple different ways you could write this. You could keep it just as it is, x plus 3 cubed minus 1 over 4. You could bring that 4 out in front and rewrite it as a product of 1/4. And obviously some students, multiplied this out and then divided everything by 4. Perfectly fine. I didn't ask for simplifying in this case, so that was, not one of my major concerns. The major concern was at least students being able to identify looking at the domain and range. All right, so before I go ahead and get to the multiple choice, just kind of check in and see some of you guys that are joining me here. Yes, Harry, I'm going back for pre-calculus. Alexa, this is not really in geometry. This is, for pre-calculus, for my pre-calculus class, dealing with functions. Sorry, Kuba, this is just what I'm going through. And Kay Pasa, hi, thanks for helping you out. You are very welcome. And Hassan, hi, sir. Please talk privately. I really appreciate. I'm happy to be able to help you out. Not sure what you want to talk privately. I'm not able to answer any individual kind of questions. I mean, this is literally I go teaching. I'm making this video, and then I got to go home, get the kids, do dinner and all that kind of stuff, and then when I get home, I'm working on creating more of this work. And obviously, when I get when I get time crunched, then you can see I start making some mistakes and things don't really write the way that I want to. For instance, like on this quiz that I did. Last night I was up till like 1 o'clock working on some documents for next chapter. And so it just kind of does get a little time consuming making all this stuff for you guys. But I really think it's going to, benefit. And then obviously, just to run a little plug, if this is something you want access to my to any of my documents, the quizzes, the tests, the quizzes, I am adding them to my Patreon account, so therefore students can use them, and obviously the support that I get through the Patreon is going to allow me to kind of move to the next level as far as getting some editing done and some reformatting of those documents, because I just printed out like all the stuff I've created, and like just for one chapter I have like this huge book, and I'm like, oh my god, I'm gonna have to like go back over and like redo a lot of this, for next year, and I'm like, this is gonna be crazy. But I don't know. That's what I guess I kind of signed up for. It was my grand idea to really kind of build out this curriculum. But I really think to position that curriculum in the best manner, you got to make sure that you go back over and correct, any of the mistakes, the problems, the wording and stuff like that. And it's too much for me to do all on my own. It's really gonna be something that I'm gonna have to, hire some people to help me out with. So that's kind of my way of like using the Patreon platform to give students access to that documents, and in return for to keep on improving all the information I'm creating. So if you're interested, the comments in or links in the description. But either way, guys, I'm going to still be creating my content out here for you guys because I want to help. And just a little also plug. If you do have any questions, feel free to add them into the chat. I'm going to do the multiple choice questions, and then I'll probably have maybe like 5 minutes that I can maybe answer some questions. So if there's anything you're working on right now in your class that you have maybe a question, work on, I'll see what I can do to help you out. All right, so now let's get into the multiple choice portion. And in this example, it's saying consider the piecewise function define, or consider the piecewise defined function. And so we have a piecewise function with f of x, or f of x as square root of negative x for x values less than 1, and then x plus 1 for x values that are greater than equal to 1. And it says evaluate for f of negative 1 plus f of 1. So basically what that means is we need to figure out what is f of negative 1. Well, negative 1 is less than 1. So this function is only defined for x values that is less than 1. So that means I'm going to plug negative 1 into that function. So minus a negative 1 is going to be equal to square root of 1, which is equal to 1. So f of negative 1 is 1. And now let's figure out what f of 1 is. So f of 1, I got to look at my domain restriction and say which domain restriction, which function relies for, at 1. And you can see here, this is x is greater than equal to 1. So for all values of 1 that are equal to 1. So I'm going to plug 1 into that equation. Use parentheses just to remind myself I'm plugging it in, and 1 plus 1 is 2. So basically, I have 1 plus 2, and you can see the answer is 3. The next one is just saying find the inverse. So again, this is kind of works into what we did on that free response. We want to algebraically figure out the response. Now these are kind of like all set into f inverse, so I'm just going to use the kind of notation that we've used before. And obviously I'm not really concerned about my work being absolutely correct here, or I'm sorry, the notation being correct. I'm just going to kind of fit in my work as best I can. So we replace f of x with y. We swap the variables. I don't know where I got a 2. That's going to be a y plus 3 over 2. And now basically I need to do all the inverse operations that's being applied to the y. So the first inverse operation is undo dividing by 2. So I'm going to multiply by 2 on both sides. Then that's going to equal a 2x equals y plus 3. And then I'm going to undo it adding that. So I'm going to subtract. So therefore, I now have 2x minus 3. Oh, let's just write in there. So therefore, I'd have 2x minus 3 is equal to y. If I was going to write that in function inverse notation, I'd have f of x equals 2x minus 3. But you can see here they're only asking for the expression. 2x minus 3 is answer A. Next example, it says find the domain and range of the inverse of this function. So we're looking for the domain and range of f inverse of x. So the important thing here is I remember that the domain and ranges are swapped. The domain of this function is the range of f inverse. So I got to see, well, what values here is what is the domain here? Let's figure out the range. Let's figure out the domain, because the domain is the easiest thing to be able to figure out. The domain in this case is all values that make the denominator equal to 0, which in this case is just 3. So it's basically all numbers except for 3. So I can write that in interval notation from negative infinity to negative 3, and then union from negative 3 to infinity. Now remember, that's the range of the inverse function, which is, sorry about that, domain. Yeah, that's the range of the inverse function, and that's what they're looking for, domain and the range. So I want to see what functions here have a range of negative infinity to negative 3. And, oh, I'm sorry, not to negative 3, to positive 3. Crap. Let's see if I can delete those correctly. Nope, I can't delete those correctly. So we'll just, there you go. Okay, so you can see here, I have this problem and I have this problem. And so therefore, that's not an answer, that's not an answer, and that's not an answer. Now, the real work kind of comes into how to find the domain of the inverse function. Well, the domain of the inverse function is the range of, or I'm sorry, yeah, is the range of the function. So what I need to be able to do is, if I don't really know the range, or at least maybe you should from Algebra 2, but if you don't remember, then we can know that if we find the inverse and we find the domain of the inverse, then we can find the range, which is going to be our, or if we just find the inverse function, we can find the domain rather simply. So again, that process is going to be, again, swapping y, and then swap the variables. So we'll have x equals y plus 1 over y minus 3. Now we can't solve for y when it's in the denominator, so I'm going to eliminate or multiply by y minus 3 on both sides. And then you can't solve for y when it's inside of a parenthesis, so I'm going to distribute by x to eliminate the parentheses. Those divide to 1, and that's going to be equal to y plus 1. Now again, I can't solve for y when they're on both sides, so I'm going to subtract a y on both sides, and I'm going to get a 3x to the other side. So I'm kind of skipping some steps here to make sure I have enough room to work everything out. So now I have y, x minus y is equal to, let's see, 1 plus 3x. Okay. Now again, you can't combine like terms here. Like typically, you know, when I was giving this to a student, I think it's a good example. Typically, we had 2y plus y is equal to 6. Now, in like pre-algebra and algebra, we would just combine like terms, right? Because we could 2y plus y is 3y, and we could solve. But you could also look into this as factoring out a y, which will leave you with a 2 plus 1 equals 6, which rewrites into a 2 times 3 equals 6, where you can now divide by 3. Well, in this case, we can't combine them, so what we're going to do is want to factor out the y in that same process. So I factor out the y, I'm left with an x minus 1 equals 1 plus 3x. And now I can undo multiplication of x minus 1 by dividing by an x minus 1. So now you can see that my inverse function, my f inverse of x, sorry.
Layla Jarrell, please report to the main office. Layla Jarrell, please report to the main office.
You can see here that the domain of my inverse now is for all real numbers except for 1. And this example says all real numbers. Well, that's not going to be it, so therefore my only answer is going to be D. All right, 2 more to go. Given the function f of x equals 2x plus 3 and g of x equals square root of x, determine f of g of x, which is basically plugging in f of g of x. So basically, all that is really telling me is I'm going to take the f of x function and I'm going to plug in the g of x function. So that's going to look like 2 times g of x plus 3. Well, g of x is square root of x, so therefore that's 2 square root of x plus 3. And therefore you can see that answer is C. All right, last but not least here, we have determine if the function is even, not, or either. A lot of students are still struggling with this concept, and you know, I'd like to kind of get into it, but I don't want to spend too much time on this. Just remember the general idea, guys, is plugging in f of negative x. If you plug in f of negative x and you get the exact function out, then the function is even. And if you plug in f of negative x and you get the opposite of the function, then it is odd. And this also works with numbers. Like for instance, if you plug in, f of 1 and, you plug in f of negative 1 is equal to f of 1, then you're good. And if f of negative 1 and is equal to, plus or minus, a, I'm not sure if this is the right idea, but that'd be minus plus, a. So whatever the value, there is, if you plug in f of negative 1 and f of 1, you're going to get the exact same value out. That means it's even. If you plug in, 1, or any number, it doesn't need to be 1, but if you plug in negative 1 and you get a positive a, well then when you plug in f of 1, you should get a negative a. So it's going to be the same number, but just opposite signs. And again, if you plug in f of 1 and f of negative 1 and you get two completely different numbers, then the function is neither. So I'm just going to use the algebraic approach and just plug in f of negative x into this function and see what happens. So I'm not going to try to count the powers, even though there are some tricks here. When you're dealing with a polynomial, you don't really need to go through all these steps. You can learn a shortcut with that just by looking at the powers. But for right now, let's just practice working, simplifying this. So negative 4, any negative term raised to a even power is going to be positive. And then 7 times negative x, so that's going to become a negative 7x. And then plus 5. Okay? And you can see here, by plugging in f of negative x, I do not have the exact same function. I have the same terms, but that's positive, but that's negative, and that one's positive. So it's not exactly the same. Then you might say, well, are they opposites? And you can see these are the same. These are opposite signs, but these are the same. So if you wanted to write it in the opposite notation, you could factor out a negative 8x to the 4th plus a 7x plus or minus 5. And what you'd see is that does not, again, satisfy the notation of opposite of f of x. So, therefore, this is an example of neither. So, all right, ladies and gentlemen, took me about 30 minutes to run through the quiz. Oh, I guess my chat got disabled, so I apologize. I'm not sure what went on with that. So either way, guys, well, I hope you enjoyed. I will look into, we'll probably start teaching at the end of next week. So I'll look into, going live probably Thursday or Friday of next week. So if you are interested in learning polynomials, the next couple live streams are going to be for you. All right. Cheers, guys.